So the general goal of this evening is to go over just a couple of the um, physical designs that have been submitted and to answer any questions that folks may have up to this point, including from those of you who may feel as though you're a little bit behind or even a lot of bit behind. There's still time. We can still get you caught up to speed. So if you're feeling lost, feel free to ask questions now. If you don't want to do it, in this public forum, you're more than welcome to contact me directly via email or phone calls, and we can make sure that we can get through any obstacles that you may be facing at the moment. So I'm going to start off by sharing my screen and just going over a couple of aspects of various physical designs. And I also wanted to show some of the resources that are out there to help you all. Here. All right. So here is one example. This is great. It lays out all the different aspects of the CubeSat build, and it has a text-based wiring diagram, which is fine. I had sent out that email maybe like a week or two ago, talking about how there are many different ways a wiring diagram can be communicated. It doesn't necessarily just have to be an actual drawing or a photo or a picture. It could be in this type of format as well. So this is accessible to pretty much anybody with even notepad you could do this with. So this should be available to everybody. This is another way. I really liked this method right here. Very basic. Basically just took a picture of a breadboard and just used colored pencils to fill in the wiring. Some folks opted to use fritzing, which I provided a video demonstration for using. If you need that, you can find it on our YouTube page. Fritzing is a great program. It makes this whole process very simple. It's basically just dragging and dropping things on the area, on the build area, and it can take a little bit of getting used to working with it. Finding the actual sensors, once you're able to get those installed into the fritzing software, it really opens up a lot of opportunities to make all sorts of different designs. If you are having trouble finding any particular sensors, let me know. I've been looking these up for a couple of years now, so I found some different sources that have pretty much every sensor that I've looked for. Now, if you watch the video, you'll have seen that, in some circumstances, you just can't find what you're looking for. And so in that way, you might have to kind of do a hybrid of, maybe something that looks a little bit like fritzing. You could even take everything that you've got in fritzing, then take a screenshot of that and then copy and paste it into like Paint or Paint.net or whatever graphic processing software comes on your computer, and you can just draw lines similar to this right here. So this is great. This was somebody who they weren't able to use fritzing, and so they kind of did it themselves using some screenshots, it looks like, and like a pretty basic graphic processing software. So here is one that actually this class is thinking about using a different type of microcontroller called a microbit. And so if you have a microcontroller that will allow you to fit more within your CubeSat frame, you're welcome to use that. just, keep in mind that the amount of support that I'll be able to provide may be limited, as I've never actually worked with micro:bit before or some of the other microcontrollers. But if it's a Arduino based microcontroller, then you shouldn't run into any issues. So yeah, so these were a couple of the different examples. If you still have not turned in your physical design, you're more than welcome to use any of these methods. If you want to talk about it further, I'd be happy to discuss it. If there's a particular method that you really want to use, but there's some sort of obstacle for you, just let me know and we can work it out. So additionally, there are lots of different resources available here in the online course. I would start, if you are working on making your own wiring diagram, I would start with module number 2, specifically with the wiring diagram that's available there. So this is basically the final build of the CubeSat for the training, if you attended in person, or if you are an online person, then the kit that you have, this is essentially how you hook it all up together. So you are welcome to send us this setup, and some of you I know are. A couple folks are looking to add in extra sensors and things, which is all right as well. But if you want to just stick with the basics, you're more than welcome to recreate this wiring diagram right here and send it in. Just having the experience of using the Fritzing software, I think, is valuable for your students. It gives them a much, I think, deeper understanding of exactly how all the connections are made before they ever actually make any connections themselves, which is very helpful. If they do it virtually first, they kind of have an idea of what it'll look like in physical form. One thing, I don't know if I mentioned it in the video that I shared with everybody on using Fritzing, is that for one reason or another, the Cduino that's in the Fritzing software lacks the SCL and SDA connections right here, which, as you can see, are pretty important. I actually did what I was talking about earlier, and this is kind of a hybrid right here, where I actually took a screenshot of the completed wiring diagram minus that SCL and SDA connection right there, and I actually pasted that into Paint and just copied 2 of the little yellow ports and then pasted them over here, and then I just used the graphic design skills required for something as simple as Paint to be able to just write in SCL and SDA here. So even this right here is a hybrid. So sometimes that's what you have to do. You have to come up with innovative solutions to problems. And so if you're running into any situation like that, let me know. If you just can't figure out how to do that, if you would like some help, some guidance, just let me know, and I can potentially do that for you. Or you can just have the green wire and the orange wire just go right over to where the SCL and the SDA should be on the Cduino. So yeah, so that's available right there in module 2. Arduino sketches that you need to actually program with are right below that. You can download them right here, this zip file. And then, as in all the modules, you have a video going through step-by-step instructions. And in all the modules as well is the Introduction to CubeSats PDF down here at the bottom, which this right here is technically the most up-to-date of any of the material that we have available. So if it seems like in one of the videos, if anything is missing, which I don't believe there should be, but if for one reason or another there was something that just didn't seem to make sense, check out the slides. Essentially, the video is me going through these slides, but I have updated things here and there. Usually they're very, very minimal things. One thing in particular is this section right here. So it's pretty much the first real hands-on part of the slide deck, which is the introduction to CubeSat flight experiments and the programming with Arduino. I'm pretty sure anybody who came through the in-person training, we went through this part of this in person. But if you are doing this online, you may be running into this issue where when you try to connect your microcontroller to your computer, there's nothing really showing up. Like you should be able to see Arduino Uno, and usually it's on like some COM port, whether it's COM3 or some other number, that's not important. But if nothing is showing up there, right? If you see no ports showing up, then these are the directions right here. And these are step-by-step, exactly what you have to find and download and install in order for your computer to be able to actually see the Arduino. Those files you can find by following these steps, or I have also put them right here in the Pathright course. So you've got your Windows file right here, and then right below that is the Mac file if you're using a Mac computer. And then besides that, it's really just a step-by-step process of going one module at a time. It's really important now that people are starting to work on the physical putting together the CubeSat to really follow these steps, because what we're doing here is we are we're going each piece of hardware at a time to ensure that each piece works before moving on to the next step. Because if you just kind of plug everything all into the breadboard all at once and then you wire it all up at once, if something's not working right in your build, it would be hard to kind of pinpoint where is the problem taking place. And just because one thing is working correctly doesn't mean that you're going to get any results necessarily. So like today I was talking with somebody about their micro SD card reader not working correctly. Even if everything is fine with the micro SD card reader, if one of the other sensors is not connected correctly, when the microcontroller first powers up, what it does is it kind of pings all of those different sensors and starts them up. If it sees in the sketch that you're working with that there is some sensor that should be there, say a temperature and pressure sensor, but it's not connected correctly to the microcontroller, it's going to send that signal to like make sure that it's there. And if it doesn't get anything back, it'll actually stop right in its tracks and it won't go any further. Not all the time, but on, enough instances that is likely to be an issue for you. So if, for whatever reason, you don't understand, you're not collecting any data or no data is being saved to the micro SD card, even though everything with the micro SD card reader seems to be hooked up correctly, it could be one of the other sensors. If one of the other sensors is not hooked up correctly, then the microcontroller won't be able to initialize everything. It won't be able to actually start saving data. So that's why in our build, in the initial training, we start with the light sensor, because it's such a simple sensor. It's easy to get that one up and running. Then the second thing that we hook up is the micro SD card reader, so that we could actually start proving that everything is working and we're actually able to save some data to the micro SD card reader. Then we move on to the more complex sensors in the build. So then the next one is like the temperature pressure sensor. And then after that, I believe, is the gyroscope accelerometer. And then we finish off with the real-time clock. So really during this build phase now, you want to take it one step at a time. You want to make sure you get your light sensor working. Then move on to the micro SD card reader. Then once you've proven that you've saved some actual data to the micro SD card reader and that everything is working up to that point, only then move on to the next sensor and wire that one sensor up and upload the next sketch that includes that new sensor, and then verify, right? Verify that everything is working, that you're getting some new data now being saved to the micro SD card before you move on to the next step. That way, when you do, if you do, and most likely you will, because that's just the nature of all of this, you will run into problems. And the whole point is to work through the troubleshooting of those problems. I know that this is ostensibly a program based on building a working CubeSat, but really it's about engaging your students with a bunch of different opportunities to troubleshoot, to work through the engineering design process, to come up with testable questions. It's really about the process. It is really cool to have the CubeSat at the end of it, working and collecting data. And yes, we are going to launch it on a high altitude balloon and potentially on rockets in the future. But really, this is about getting your students into the nitty gritty and the hard work of running into a problem and coming up with solutions to that problem. So working through it one sensor at a time is really the best way to ensure that your students are able to actually find the problem without getting too overwhelmed and lose interest and give up. Because if you have like a big giant mess of wires and sensors, it's easy to get overwhelmed and to just not be able to find the problem and not want to continue working on this, get stressed out. So yeah, that process that I just outlined is in my experience the best way to kind of chase down a problem and identify it and then come up with a solution. So if you are running into any of those situations where students are getting frustrated, and unfortunately one of the most useful ways to deal with these types of problems, especially wiring problems, which can also be one of the most frustrating things, and some of you experience this because I did this to you in the training, is to literally just unplug everything from your breadboard, take out all of the wires, and start again at the beginning. I know that especially if you've put a lot of work into it up to that point, like that seems like a horrible idea. But trust me, there have been plenty of times where like I've looked closely at all of the wiring and like everything looked perfectly fine. And for whatever reason, things still just were not working. But once you pull everything out and put everything back in, sometimes it could just have been something was just like not plugged in all the way. It's unfortunate that can be such a big problem and stop everything from working, but that's just the nature of electronics. So as hard as it might be to actually do it, you may have to go back a step, go back multiple steps in order to figure out where things started going wrong and then work your way back to where you were previously. So I encourage you to do that. I encourage you to do that with your students. Explain to them, we're doing this because, we need to figure out what the problem is. I know that it can seem like, you're ruining some of their hard work, but really explain to them, like, this is about you learning the process of troubleshooting and getting through things. I think that in today's day and age with so much instant gratification, right? You can basically have anything that you want within 24 to 48 hours from Amazon or instantly from streaming services and whatnot. I'm afraid that we may be instilling in our young people, especially, this idea that, you should be able to just have everything instantly, that nothing should require, hard work. And so this whole program is trying to, in a way, combat that mentality, to realize that, sometimes it takes going back to the drawing board. Sometimes it takes having to take your work apart and put it back together again. It takes hard work sometimes to solve problems. And if you or your students are really, running into issues and you just can't figure it out, please, please, please get in touch with me. I will either explain to it with bullet points and step-by-step actions that you can take to work through your issues, or I can hop on a call, whether it's a phone call or a video call. I can talk directly to you. I can talk directly to your students, whatever is best and easiest for you. And it's most likely to help you, progress through the program. So with all of that being said, I would like to open up for any questions that folks might have currently. If I can answer them, awesome. If I can't answer them immediately, I promise that I will take the time to, dig into it with a little bit of research, and I will get back to you as soon as I am able.
Before folks leave,
yeah,
could you ask them about the pictures, Rob?
Oh yeah, sure.
No.
So before we even get to the questions, then if you have the ability to, please, if you could document any of the process that your students are going through, especially troubleshooting. If they're hard at work trying to figure out problems, we'd love to be able to use that to promote our programs, but also to recognize the students themselves. If that's something that you and your students are comfortable with, we'd love to be able to share your stories in our social media, as well as for future grant proposals that we are often writing, in order to expand this program out to even more students and more classrooms. The more we can show, this happening in the classroom and the impacts that it's happening. If you could write up maybe a paragraph or two about any impacts that you're seeing, any stories, any obstacles that you're running into, any lessons learned, anything about this whole process, even if it's bad. Like if you have criticisms about how we've been operating the program, how I've been supporting you in any way, please let me know. I will not be upset. My feelings will not be hurt in any way. You will be doing me and Teachers in Space a huge favor if you, help us to make our programs better. Anything else you wanted me to communicate, Jim?
Yeah, and that could be as simple as just photos of kids working too,
Yeah.
That'd be great to have like paragraphs. That'd be great. But also, if anybody in the New York group is on, if you took any pictures of Rocco's station, we all had a chance
The
to
radio
visit
station.
his remote radio station. So we're in need of pictures. For some reason, we got quite a few of the inside, and if you have any of those, please send them along too. But the exterior, the whole trailer is set up, a couple of those would be great too if you have them. Thanks.
Yep.
Thanks, Noah.
All right. Yeah, so then at that point, let's open it up. If anybody has any questions, please let me know. I'd be happy to answer them right now.
Hello, Noah.
Hello.
I just wanted to share that I'm really appreciative of the time you took to help us out with the students, the group of students, and exactly what you mentioned right now. That's what happened to us, where everything was working, and then all of a sudden it stops. And so you mentioned maybe it looks good, so maybe having to restart. And so desoldering, because we also saw that we made some mistakes when the students soldered in the pins. So I did reach out because I saw the desoldering machine and I saw videos and I thought, okay, it's not working. I couldn't get it to work. So I reached out for help, and our tech person from the district came over and he handled it, Mr. Nunez, and he actually said the same thing. It looks good. So what's going on? So we tried it, the same thing. And again, he's like, you start from the beginning. And so the students went ahead and actually they are excited to start all over.
Oh, nice.
They're loving Excellent. It. So they didn't feel like their work was in vain. So they're loving it. And then making sure that, yes, even though the wiring, the color code, the color doesn't matter, but the coding for them to be organized. So then again, we took from other packets and then we now correlating them to the diagram with the colors. And so I had them, so we're starting over because we just got back from break. We're testing next week, we're dual language, so we're testing. We always are testing, but making the time. And so I had them write them down, diagram all the sensors to make sure, look at them again. And then, so Mr. Nunez was so excited, he's actually coming back to check on their progress, to see how they're doing. But Thank you so much for taking the time. And yes, it is teaching them the importance of just going back to the engineering process. We start again, we test again.
Yeah, absolutely. I mean, that's how engineering works, right? I mean, there was a time where engineers had to figure out how much load could you put on the wings of an aircraft. So what did they do? They went out and they built the aircraft, and then they put weights on the wings until they failed, and then they went back to the drawing board and made sure that they were strong enough to withstand that kind of load. So I mean, engineering is kind of about breaking stuff, right? It's about, seeing how far you can push hardware to the limits before, it either fails or something has to be, redesigned. So by
That
going
trial
through,
and error.
Right,
Yeah, the
exactly.
trial and error. Yes. Yeah.
right. I mean,
it.
that's engineering, right? That's science, right? The scientific method. It's all about coming up with an idea, testing that idea, and seeing if it conforms with what you thought would happen. And if not, you go back and you change, what your plan was and try it again. And then having other people try it out, make sure that, it wasn't just a fluke. Right. And so I also love to hear, that kind of story. Like, that is the perfect thing when you have other people in your district or your school, get involved, right? Especially administrators or tech people. I personally, in my experience as a teacher, I butt heads a lot with our tech people. I actually got into some good amount of trouble fixing other teachers' computers and whatnot. The tech people did not like that at all. But if you can bring those tech people into the classroom and they can see what it is that you are doing, they're tech, right? They're interested in computers and electronics. That's why they do the jobs that they do. Like, I can only imagine that if they, get a taste of what you and your students are doing, that they will only be supportive and be a great benefit, right? If you are looking to expand this program at your school, if you're looking to get more resources, if you're looking to get more CubeSat kits, if you want to go to more of these trainings, by having more of the folks in your district involved now, those are more voices that can vouch for you going on into the future.
And on that note, yes, right now a budget cut was there, so we weren't able to proceed, I think, with adding more teachers. So that's why he's interested in going and maybe getting more information, working with the kids, and then hopefully getting that that budget back into place so
Right.
that they can continue with it. But that was one of the things that also he wanted to go see what it was that we were doing. But
Right.
thank you so much. Mm-hmm.
Right. And generally when anybody sees, especially students working with these CubeSats, like, they're almost always like, wow, this is awesome. This is amazing. This is all commercial off the shelf stuff, right? This is all stuff that anybody can get their hands on. It's not super expensive. I know that there are a lot of other STEM programs out there, whether they're robotics based or computer science based, that a lot of times, you can only get stuff from that one organization or that one company. And sometimes it's really expensive stuff. Luckily, Arduino is open source, so you can get all sorts of different Arduino based microcontrollers. You don't have to only get the ones that we provide. Like, we use Seeduino ones from Seed Studio because they're the cheapest yet best quality that I have found so far. But that doesn't mean that that's it, right? There's could be other stuff out there. Pretty much any sensor that Adafruit produces, which is what is predominantly in our CubeSat build, you could also get from SparkFun, which is another very well-known company based in Colorado. You can also get them from DF Robot, a Chinese company. You can get them from a lot of other companies. All of you have probably already heard me a bunch of times talk about, like, why you should avoid generic stuff versus the name brand stuff. But that's the beauty of all this, is that this is very accessible. It's very open source. And even if you never build another CubeSat with your students ever again, the experience that they're getting by putting this together is it's gonna be very helpful for them down the road, whether it has to do with electronics or not. Even if it's just, they're getting a taste of problem solving, right? That is so helpful.